Alright, well, hello everyone. Good morning or good evening, whenever you're watching this. This is going to be a lesson, some new material on some intro to trigonometry. Just a few topics on what trigonometry is as it's related to geometry. What we're doing is we're going to be branching away from a lot of Euclid's the elements stuff that we've been looking at. So, all the propositions and theorems and things like that. We're just going to look at this chapter for a little bit before we talk about some properties of circles. And then our last project will be on volume, 3D geometry and stuff related to that. I was going to do some things related to the Pythagorean theorem and related to similarity and dilations more, but as it is, it's a little difficult. I think it'd be a little too much to try and do this through the whole electronic format, so we're gonna kind of skip over that and just go straight to some trigonometry stuff. So for these videos, treat it like you would be taking notes in class normally. So get your notebooks, get ready to write things down. Feel free to pause the video. I'll try to ask questions here and there that you can think about, and that should be helpful. Help you stay connected. And of course, always feel free to email me if you have any questions, or attend the Zoom office hours that I'll be starting this next week. Right, so trigonometry. Well, what is it? Well, it is going to be a study of angles, trigonometry, and how they relate to triangles, or the angles of triangles. Okay, so what we're first going to do is think about a special type of circle, right? And if we were to graph it, well, this circle is going to be represented by this graph here. X squared plus y squared is equal to 1. Now this is not our usual way of writing an equation. Normally of y is equal to some expression involving x here. And in fact, we have y squared as well. What this is going to give us, though, is this is going to give us something that is not considered a function, right? A function is is a graph where if we have some graph on our x and y axes, the Cartesian plane, and if you can draw a vertical line and only intersect that graph once, then it's a function. But for a circle, right, we can draw a line and intersect it twice at the most, or one time if you're on the very edge of the circle, which we call a tangent, right? We looked at tangents. If it intersects that circle just one time. Now if it intersects it twice, well, what does that mean? It means for a particular x value, we can get two y values to be the answer. Right? If we perhaps said, well, if x is 1/2, well, what would y be? Plus y squared is equal to 1. Well, we would get y squared is equal to 1 minus 1/2 times 1/2 is 1/4. So y squared is equal to 3/4. Or y is going to be equal to plus or minus the square root of 3/4. Plus or minus, right? Because if we put in a negative here for y, a negative squared is positive, and a positive squared is also positive. So we can get two answers here. And we would see that on our graph. So let's draw our circle here a little bit more complete. We will say that the furthermost right point is going to be 1, 0 for this graph. Another way that we write graphs like this for circles is the x value squared plus y value squared is equal to the radius squared. Now if you wanted a radius of 2 for a circle, then you would put in, instead of 1 here, put in 4, or that'd be 2 squared. In this case, our radius is 1, and we're left with just 1, since 1 squared is 1. We'll try to draw a circle here. Oh, it's an ugly circle. Oh well, okay. 0 comma negative 1 will be the bottommost point. Topmost point will be 0 comma 1. And this point will be negative 1 comma 0. Since our circle is centered at 0, 0, we don't have any parts of our circle, we don't have like a weird coordinate here, right? We've made it so that the topmost, leftmost, rightmost, bottommost points are all in terms of 1, right? And we call this the unit circle. Now the unit circle has some nice properties to it. One of them is that if we want to find the arc length at a certain angle, so let's say that we look at an angle like this, 30 degrees, and we want to find the arc length, so the length of this curve along the circle here, we are able to figure it out very easily because the radius is 1 all along the circle. So 1 and the angle is 30 degrees. So the arc length is, well, also 30 degrees. Or if we're including our units here, it would be 30-degree units. Different kind of way of talking about arc length. Okay, so that's cool. Since the radius is always 1 for the unit circle, then the arc length is always just equal to the angle. That's one nice property. In general, for trigonometry, we use the circle of radius 1 because it makes the math more simple. We could do, we could use a circle of like a radius 2 or 4 or 5 or something else, but what will end up happening is our coordinates will just be multiplied by that number. So we're just making things more complicated. Okay. Now, what we want to do is say, what is the coordinate of this point? So, I know my circle is really bad here. Maybe I'll just draw another one real quick. It's a little bit better. So if we imagine this point here, we know that this length is 1, and we know that this length is 1, but we don't know what the x value is here because this point is further to the right of this point. It should be a little bit further to the right. So this is not going to be, the x value here is not going to be 1, right? Or x and y value. How do we figure that out? Well, we're going to use triangles to do this and the Pythagorean theorem. So if we have a triangle here, we can get a right triangle by drawing a line straight down. Okay? And that way we have a right angle here. So we know that this is 30 degrees. We know that this is a right angle. And we know that this is 1. The hypotenuse of this triangle is 1. And our goal here is to find the x and y value at this point. We can also say that this point is 0, 0, 0, right there. Well, first thing to notice is that the length of the base of this triangle is going to be x. Right? When the coordinate says, since we're starting at 0, 0, that we're going x in this direction and then up y. Right? This distance is y. All right. So we're trying to find really both of these values. Now we couldn't use the Pythagorean theorem here yet. We would just be getting the equation of our circle, right? X squared plus y squared is 1 squared, which we had up here, but that doesn't help us solve for x or y, so we gotta do something else. So what we can do is a little trick here. Let's redraw our little triangle, where if this is 1, this is 30 degrees, I'm just going to replicate this triangle, make a copy of it, which we could do with our earlier postulates. I guess that was postulate like 19 or something. And let's make that copy, sharing this leg here, but going downwards. That does not look the same. Well, you're gonna have to pretend that that is this exact same triangle, so that this is also 30 degrees and this is 1. Okay. So if this side is 1, this side is 1, this is 30 degrees, this is 30 degrees, what else do we know? Well, we would know that this would have to be 60 degrees, and this would have to be 60 degrees, right? Because 30 plus 90 is 120. The missing angle here has to be 60 then. It's 180 minus 120 is 60. So let's redraw our triangle here. So we have that this is 60 degrees, this is 60 degrees. 30 and 30 is 60. So we actually have an equilateral triangle here. And with equilateral triangles, we know that all sides are equal. So this side and this side and this side are all 1. Just despite my picture not looking very accurate. But that's all right. So this length here is 1. Now, since we made a copy of this triangle, we know that this length and this length are the same. We call them both, I guess we should call them both y, since they're talking about our heights here. So we know that y plus y has to be equal to the total length here is 1. So 2y is 1, so y is 1/2. Right, so we cut it in half. All right, I'm gonna redraw our triangles one more time. So that means for a triangle here, we've actually solved for the y value, right? The y value has to be 1/2. And this also has to be 1/2. You know, this is 1, that's 1. So our y has to be 1/2. Our x value, right, is still unknown, this length in the middle, but we can use the Pythagorean theorem to solve for that. So we'll say x squared plus 1/2 squared is equal to 1 squared. So x squared is equal to 1 minus 1/2 squared. 1/2 squared is the same as 1/2 times 1/2. I think we did that up here, right? So it's 1/4. X is equal to, x squared is equal to 1 minus 1/4. So x squared is equal to 3/4. So x is equal to plus or minus the square root of 3/4. And we'll go a little further this time and say that it's equal to plus or minus the square root of 3 over the square root of 2. Over the square root of 4, which is equal to the square root of 3 over 2. Plus or minus. Well, is it going to be plus or minus? That's our question. Since this is the x value, we look at a triangle here, we're going in the positive x direction for the x-axis, right? So it actually has to be positive. We can scratch out our minus. Our x value has to be square root of 3 over 2. So we did actually figure out our coordinate. Our coordinate of this point here has to be the square root of 3 over 2 comma 1/2 for the degree of 30 degrees. All right. So we've solved for one coordinate here. That's pretty cool. I wonder if there's other things we can do. It turns out there is. If we draw another unit circle here, and we want to find the coordinate at 45 degrees on the unit circle. Okay, so that point here is still 1, 0. Up here is 0, 1. Our middle is 0, 0. We're going to find x and y for 45 degrees. We will make a triangle again. So I'm going to draw a line straight down, make this a little bit bigger so we can see here. Trying to find this coordinate, x, y. We know that this is 0, 0. We know that this is 45 degrees. Got a right angle there. And we know that the radius is 1. Right? So this length is, x. This length is y. Well, first question we should ask is, what kind of triangle is this? It's a right triangle, but what else? Well, since we have 45 degrees, the other angle here also has to be 45 degrees, which means that this is an isosceles triangle. Redraw it again. So this is 1, and both this side and that side are the same, right? Properties of isosceles triangles says that we have two sides that are congruent, and obviously the leg and the hypotenuse can't be congruent because then they'd be the same length, and that wouldn't make sense for a right triangle. So instead of calling them x and y, they should be the same value. So I'm just going to call them both x, since they should be the same number, right? This is a variable representing a number, so they should be the same. And now we're actually going to use the Pythagorean theorem again. That's also 45 and 45. So x squared plus x squared is equal to 1 squared. Since these are like terms, we can combine them and get 2x squareds. It's equal to 1. So x squared is equal to 1/2. So x is equal to plus or minus the square root of 1/2. Square root of 1/2, what is that? It's not 1/4. We have to do a little work here. Well, this is the same as the square root of 1 over the square root of 2, which is the same as 1 over the square root of 2. So one thing in trigonometry that we would like to do is we want to rationalize our fraction, which means we don't like the little square root on the bottom here. We want to have it at the top, if anything. And we can change that by multiplying the top and the bottom by the square root of 2. When that happens, the square roots will cancel on the bottom. We just have 2 on the bottom, and on the top we have the square root of 2, which is just nicer. We'd like to use that. Okay, so if both of these are the square root of 2 over 2, is one of them positive and one of them negative? Well, we look at our little graph here. Moving the positive direction for x, we're also moving the positive direction for y, so they're both going to be positive. So our coordinate here that we were trying to find is the square root of 2 over 2, comma, the square root of 2 over 2. All right, got some weird numbers here, irrational numbers. So we can find the coordinates of 45 and 30 degrees. Maybe you're wondering, well, where does cosine and sine come into this? Maybe you've heard of those before, or you saw them before in a previous math class. Well, what we're going to do is create a relationship between these values on the unit circle, like square root of 2 over 2 and square root of 3 over 2, and compare them to the angles on the unit circle. And what these are going to be is just representative of those relationships. One way we can do that is by looking at all the values on a unit circle and then making a graph. So here's the big hint. The process that we used for finding the angle of 30 degrees and 45 degrees can help us find similar coordinates for all of the different values on the unit circle. And we're going to find that only the angles that are multiples of 30 and 45 degrees are possible to find nice values, at least for now. So we can also find an exact coordinates using for 60 degrees, as well as 90 degrees. We actually already found that one, 0, 1. As well as, let's add 30 to that. We can add 45 to 90, right? We can add 45 to all of these and keep on getting values. 150, 180 degrees, 210 degrees, 225 degrees, 240 degrees, 270 degrees. 270 degrees is going to be going straight down. 90, 90, 90. 300 degrees, 315 degrees, 330 degrees, and 360 degrees, which is the same as 0 degrees. We just gone around a full revolution. So these are the angles where we can find coordinates. The coordinates at these angles will all use one of these values. So we've found, sorry if you hear things, 4 of the roommates. So they could be plus or minus values of any of these numbers here. So let's draw a little circle here. at this point, okay, I'm getting loud. 1 second.
In the morning,
Hey,
when you rise.
can we not yell while I'm recording? Thanks.
Hey,
Yo.
hey, just a thought. If you're gonna be doing this, like on a recurring basis, maybe like a sign on the board letting us know that like recordings in session would be helpful.
Although I did hear you talking.
I mean, you walked through here, you knew I was recording.
It's
Okay,
fine.
okay.
But if you could, it would be
Sure.
helpful.
Yeah.
But yeah.
Okay. All right. What was I doing? Oh yeah, we're looking at unit circle. You can look up one of these on like Google and just find a nice little picture, better than I'm about to draw here. But if we were to map these out, 30 degrees, 45, and 60 degrees, 90 degrees, 120, 135, 150, 120, 135, 150, 180, 210, 225. 210, 225, 240, 270, 300, 315, 330. All right, and the coordinates of each of these are going to be very similar. So 30 degrees, it's the square root of 3 over 2, comma 1/2, which is what we found. This is the square root of 2 over 2, square root of 2 over 2. For 60 degrees, we could set up a triangle again. We'll just draw a little triangle here. And now this is 60 degrees. And we could do a very similar process of finding a triangle on the other side and creating another equilateral triangle. But the coordinate here will just be switched of these two. So this is 1/2, comma, square root of 3 over 2. All right, this is 0, comma 1. And for this side is just the same coordinates as these three, but now the x coordinate is negative. So for this one, now it's negative 1/2, square root of 3 over 2. And now we take this one, it's the negative x value. And this is negative 1, comma 0. And for the bottom half, it'll be all these same coordinates here, flipped this way. And now all of these y values are negative. Right, so it should be very repetitive once you can remember these 5 values. So cosine and sine is just going to be the relationship between the angle and the x value for cosine. So cosine kind of has sine in the name, right? It's related to the x values. And specifically, we'll say that cosine of a given angle is going to be equal to the relationship between the x value. Let's look at this one. So x value here is square root of 3 over 2 over the radius. The radius is just 1, right? And the radius, since the radius is 1, it's equal to really just x for the unit circle. If we looked at a circle with radius 3, then we could just plug in 3 here, and we would get a different relationship. And for sine, it's the relationship between y and the radius, where the radius is 1 for the unit circle. So sine of theta really is just the y value going straight up at these points. All right, let's see where we are at time. Okay, so this kind of relationship of the circle and these coordinates can help us do a few things. Later we'll look at graphing, I think. But for now, I want to look at some ways we can solve problems. Okay, so here's what we're going to use. We're going to say that cosine of an angle is equal to the x value over the radius, and sine of an angle is equal to the y value over the radius. Right? These are just relationships that we have defined. Okay, and we can use these for right triangles again. So before, for using the Pythagorean theorem, we'd have to know two side lengths in order to find another side length. For this, if we have an angle that we know and some value, one of these sides, any of them, let's pick this one. So we know this is 5, and let's say that we're trying to find the hypotenuse, which is really the radius. So we'll call this z. All right, find z. Well, what we can use is, since this is referring to the y value, right, we can use sine. So sine of 30 degrees is equal to 5 over z, which is the radius. Right? If we imagine this is on a circle, right? So this is the radius here. All right, and then we can solve for z. So z, multiply z on both sides. It's equal to 5. We divide both sides by sine of 30. And we just have to figure out what sine of 30 is, which we figured out before in our unit circle. Right, so the y value, remember sine is equal to the y value at 30 degrees would be 1/2. So 5 divided by 1/2. Right? So what is that? We flip and multiply to get z is equal to 10. So we solved for a missing side of our triangle, just using our little sine and cosine relationships. Let's look at another one. What if we have something like this, where this is 45 degrees, and let's say that our radius here is 7. Okay. Well, we could use cosine or sine here. We can think about where our center of our circle is, which would be here. Right? So our x value is going this way, our y value is going down. Well, let's use, how about cosine? So we'd say that, oh wait, this is not right. Did I draw my circle wrong? I did draw my circle wrong. That doesn't make sense. Let's draw this again. X and Y. So really, this would be the angle we should be thinking about in order for this to make sense. Wait. Oh, did I draw this right? Yeah, it's easier to think of it as this angle since we're using X and Y. Yeah, so the circle was in the right place. I was just thinking of the wrong angle here. So for cosine of 45 degrees, we know that that's equal to the X value over the radius, which is 7. All right, we can solve for X by multiplying both sides by 7. If you look at our unit circle here, the X value of the square root of 2 over 2, the X value of 45 degrees is the square root of 2 over 2. So we can substitute okay, so we get that our X value is equal to 7 times the square root of 2 over 2, which isn't going to simplify at all, but we can solve for it. If we were to multiply that out, we would get something close to 5 point something. All right. I think that we will look at, I don't want this to go too long. Where are we at? 30 minutes. I think that we will look at values we look at other relationships, such as tangent, at another time. We've looked at tangents before. It actually has two meanings. One in trigonometry is referring to this relationship between sine and cosine, and the other is referring to a line that's intersecting a circle once. So kind of confusing. That is, they use the word twice the same way, but we'll look at that later. For now, the homework that we'll have for this week will be looking at the unit circle and different degree angles and solving problems like this using sine and cosine. If you have any questions on this, feel free to email me or come to my office hours this week. And you can ask me anything if you have any questions. All right, that's it.